Hello, I'm Janet. Today we'll be talking about indices. In our lesson today we'll be talking about indices. Now, indices is a short form of writing numbers. Let's say, for example, we have the expression a raised to the power of n. What this means is the number of times a is multiplied by itself n number of times. The number of times a is multiplied by itself n number of times. What do I mean by this? Where we have 3 raised to the power of 4, number of times 3 is multiplied. This is the n and this is a. So the a is the base, which is the 3 is the base. 3 is the base, while 4 is the index. So the number of times 3 is multiplied. That gives you indices. So we have 3 times 3 times 3 times 3. The number of times 3 is multiplied is 4 times. So we have 3 raised to the power of 4, giving us back the original question. Now, whenever we are talking about indices, we have to deal with the laws. We have the laws of indices. We have the multiplication law. So for the multiplication law, when you have a raised to the power of n multiplied by a raised to the power of m, you add the indices a raised to the power of n plus m. So an example is given if we have 2 raised to the power of 5 times 2 raised to the power of 2. Mind you, it must be the same base before you can add the indices. So we have 2 raised to the power of 5 plus 2. That gives us 2 raised to the power of 7. Then we have the division law. For division law, we have a raised to the power of m divided by a raised to the power of m, which is still a raised to the power of m. Sorry, this is n. A raised to the power of m over a raised to the power of n, which is a raised to the power of m minus n. Okay, so where we have the base to be 5 raised to the power of 3 divided by 5 raised to the power of 2. What we have now is 5 raised to the power of 3 minus 2. You subtract the indices, so we have 5 raised to the power of 1. Alright, then we also have the power in power law. Power in power law. Okay, so where we have a raised to the power of m raised to the power of n, that's power in power law. We have a raised to the power of m, you multiply the powers times n, which gives us a raised to the power of mn. Now, giving an example, we have 3 raised to the power of 2, everything in bracket, raised to the power of 5. What we have is 3 raised to the power of 2 times 5. It is now 3 raised to the power of 10. Okay, that's for power and power law. We also have negative power law. Negative power law. So for negative power law, we have a raised to the power of minus n. That gives you 1 over a raised to the power of n. That's for negative power law. That means when you are given 4 raised to the power of minus 3, it becomes 1 over 4 raised to the power of 3 to get rid of the negative. Then we also have the zero power law. Zero power law states that whatever number or letter raised to the power of 0, that gives you 1. So if it is 9 raised to the power of 0, 9 raised to the power of 0, it's 1. Even if it is 1000 raised to the power of 0, that equals 1. That's for zero power law. Then we also have the fractional power law. For fractional power law, we have a raised to the power of 1 over n. This is the power is fraction, so it becomes the nth root of a. Everything raised to the power of 1. Okay, because it's 1 over n. Now, where we have 8 raised to the power of 2 over 3 as an example to explain that law, we have the root there is the third root. The denominator is the root. The third root of 8, everything raised to the power of 2. The third root of 8 is 2, meaning 2 times 2 times 2, that will give you 8. Everything raised to the power of 2. Okay, that's that. Except otherwise, if you ask you to leave your answer in index form, you can leave it this way. But if you are to express your answer, you know that 2 raised to the power of 2, that gives you 4. Now we have the last one, which is the equating power law. For the equating power law, where we have a raised to the power of m equal to a raised to the power of n, that will give us m, you equate to the power, m is equal to n, provided their bases are the same. Now, if we are given, we have 2 raised to the power of x equals 2 raised to the power of 5. They are the same base. The final answer will now be, of course, we have 2 raised to the power of x is equal to 2 raised to the power of 5. So where we are equating the powers, it will now be x is equal to 5. Alright, so these are the laws of indices. I'll treat some examples to explain these laws. Here are some examples to explain the laws of indices. Now, to solve this, we'll follow the steps or the laws of indices. For the 32 raised to the power of 3 over 5, we have 2 ways you can do this. You can express 32 as a product of the prime factors, like we have 32, expressing it as a product of a prime factor. The least prime factor that can divide 32 is 2, and when it divides 32 is 16. 2 divides 16, that's 8. 2 divide 8 is 4. 2 divide 4 is 2, and 2 divide 2 is 1. So the expressing 32 as a product of its prime factor is now 2 times 2 times 2 times 2, that times 2. That means it's 2 raised to the power of 5. Remember, from the beginning, from the law, we said the number of times a number multiplies itself. We are talking about indices. So the number of times 2 multiply itself is 5. The base is 2 and the index is 5. So we use this. So 32 now becomes 2 raised to the power of 5. Everything raised to the power of 3 over 5. Remember power in power law. So we have 2 raised to the power of 5 times 3 over 5. So let's make it to fraction form. So 5 here 1, 5 here 1. We have 2 raised to the power of 3. That's the final answer. Or we can use the fifth root of 32. This is the first method. The second method is using the fifth root of 32. So we have 32, 3 over 5. The fifth root of 32, everything raised to the power of 3. So number of times 32 a number of times a number can multiply itself 5 times. That's 2 will multiply itself 5 times. So you have the fifth root of 32 is now 2 raised to the power of 3, which is the answer. Then the next one, the number 2 is 1 over 4 everything raised to the power of 3 over 2. Negative 3 over 2. Okay. So what we have here is 1. This is the way I'll do mine. I'll use the second method where we have the square root of 1 over 4 everything raised to the power of minus 3. The square root of 1 over 4 is 1 over 2, meaning 2 times 2 is 4, 1 times 1 is 1. 1 over 2 raised to the power of minus 3. So to get rid of the minus, we have, and you know that this minus 3 is for both numerator and denominator. So what we have here is 1 over 1 over 2, everything raised to the power of 3. I like to express it this way, where 1, this over becomes divide 1 over 2 raised to the power of 3. So we have 1 times 1 raised to the power of 3 is still is 1. Then 2 raised to the power of 3 is 8. So once this division becomes times, the number below swap to the numerator and the number on top goes down. So we have 2 over 1 raised to the power of 3. So what we have here is 1 times 2 raised to the power of 3 is 8, and 1 raised to the power of 3 is 1. So what our final answer becomes 8. Now the next one is y raised to the power of 1 over 2 times y raised to the power minus 1 times y raised to the power 3 over 2. So remember your multiplication power law, you add their index. You have y raised to the power 1 over 2 plus minus 1 plus 3 over 2. So let me add up first before I subtract. So I have y 1 over 2 plus 3 over 2 plus times minus minus 1. So what we have is y 4 over 2. This is like fraction, we already have 2, so 3 plus 1 is still is 4 minus 1. When you look for their LCM is still 2. So we have y LCM is 2, 4 minus 2. That gives us y 2 over 2. 2 over 2, that's y raised to the power of 1. That's the answer for that. Then the last one is for decimal fraction, where we have 0.00001 raised to the power of 2. This becomes 1 over, we'll turn it into fraction. This is decimal, so I'll turn it into a regular fraction. The number of times the decimal point moves, that's the number of zeros you will get after 1. 1, 2, 3, 4, 5. The decimal points move 5 times, so you have 1, 2, 3, 4, 5. Everything raised to the power of 2. So this becomes 1 over 10 raised to the power of 5. But when you multiply 10 5 times, it will give you 100,000. So 1 over 10 raised to the power of 5. Remember our negative power law. This becomes a negative power law. This becomes 10 raised to the power minus 5. Everything raised to the power of 2. Negative power law. Negative power law will result to this or this. It goes back and forth. So then your final answer is, we have power in power law. 10 raised to the power of minus 5 times 2. So what we have is 10 raised to the power of minus 10. Now, if you are asked to leave your answer the way the question was given, you will bring it back to now become 1 over 10 raised to the power of 10. But we are to leave our answer the way it came. Instead of making it 1 over 10 raised to the power of 10, it becomes 0.0000000234567801. Okay, so we have 1. This is the final answer.